We are now talking about the graphs of tangent and cotangent in this video. So these are the final two of our 6 trig functions that we had to deal with. Now, tangent and cotangent are a little bit different than our secant and cosecant. And let's take a look and see what those parent functions look like. Okay, so here's Desmos. Okay, so we can see that our x-axis is evenly spaced out from negative 2 pi to 2 pi. So I'm going to go ahead and click on tangent. And notice what we see. We see some tan lines. Okay, and it looks like this pattern of this cubic graph looks like it's repeating. Okay, and it looks like it's repeating every pi. So notice that there's an asymptote at negative pi over 2. There's an asymptote at pi over 2 because our graphs are not, they're approaching that line but never crossing it. And again, the distance from negative pi over 2 to pi over 2 happens to just be pi. And then it repeats. And so we see this cubic graph now going through the point pi. And again, pi over 2 and 3 pi over 2 don't exist on our graph. So again, it looks like they'll be asymptotes. Okay, so cotangent, since it's reciprocal of tangent, it should look pretty similar, just backwards. Okay, but what's interesting about cotangent is that we see, instead of the asymptote being at negative pi over 2, this time we actually see an answer. We see that it's crossing it. This time we see it looks like an asymptote at the 0, and it looks like there's an asymptote at the pi, maybe at the 2 pi as well, negative pi. So period is still, the length of our graph is still going to be pi, okay, but it looks like it's just been shifted over a little bit. Okay, so again, two different graphs for tangent and cotangent. So let's look a little bit closely at this. Okay, so here's what our equations look like. So y is equal to a tangent. So we still have an a value, we can still have a b and a c, and we can still have a d, right? Or again, we can see, and again, we can use the f of x if we really want to. And again, a cotangent bx plus c, and then plus d. Now, just like secant and cosecant, these graphs go on forever and ever, upward and downward. So technically, you don't really have an amplitude, but our a value still does tell us how things are being stretched out. Okay, so our period we said was pi. So now we'll just take our pi and we'll divide it by b. So again, it gets cut in half. Now, the question was, why are some of the asymptotes at pi over 2 or negative pi over 2 or 0, pi, things like that? And if we think back, tangent of theta is equal to y over x, and cotangent of theta is x over y. So again, they're reciprocals of each other. So when I have a unit circle, something like that, and I have my points, so 1, 0, this is 0, 1, negative 1, 0, and finally down here 0, negative 1, okay? Depending on if I'm talking about tangent and cotangent, things are going to be undefined. So when you have, for tangent, when you have the x in the denominator and the x happens to be 0, right, so something up here, we know that these are going to be undefined, right? So that makes sense that it's undefined and it has asymptotes there. Whereas where cotangent has the y, it'll follow the x-axis, right? So anything on the x-axis for cotangent ends up being undefined as well. Okay, so things to kind of think about. Okay, so how do we actually find these asymptotes? How do we find our intervals? Okay, so let's take a look at tangent first. So to find the intervals for tangent, what we want to do is we want to solve the following equation. Oops, solve correctly. We want to solve this inequality. Negative pi over 2, and then this will change, bx plus c, so I'll put it in a different color, and then pi over 2. Now, you might be thinking to yourself, why are we starting with negative pi over 2? Why are we ending at pi over 2? Okay, well, again, if we recall in blue, 0, 1 is going to be undefined. So that makes sense that pi over 2 is going to be undefined. But what about negative pi over 2, right? So why that one? Well, let's recall that tangent, when we looked at the graph, it kind of looked like this. It looked like a positive cubic. So notice that it starts negatively and ends positively. We always want to try to start in the first quadrant. And when I look at the first quadrant, my tangent is positive in the first quadrant. So that means that's like the top half of my tangent. So where would my bottom half of my tangent be? Well, it would be below tangent that was positive. So it would be in the fourth quadrant. So that's why we're going to stick to these two quadrants. Now, even though it's really quadrant number 4, notice that I didn't call it 3 pi over 2, because 3 pi over 2 means that I went all the way around through my second and third quadrants to get to that. I don't want to include my second and third quadrants. I purely just want to look at my first and fourth. So that's why instead we are calling it negative pi over 2. So instead of going counterclockwise, we want to go clockwise, right? So it's a coterminal angle. So again, negative pi over 2, pi over 2, these are your vertical asymptotes. Okay? When there is no B and or C, your intervals will always be these numbers, negative pi over 2, and then negative pi over 4, and then 0, pi over 4, and then pi over 2. Okay. Your tangent pattern, so tangent pattern, okay. Now, your tangent pattern, I want you to think back, your graph is going lower and lower, right? We want to think of the smallest value that it will ever be. The smallest value that a tangent will ever have is negative infinity. Are we ever going to graph that? No. But again, it helps us. Now, pi over 4, negative pi over 4, again, one's going to be positive, one's going to be negative. Remember that pi over 4 is the same as 45 degrees, right? And so the tangent of 45 degrees gives us 1, which means if it was a negative 45 degrees or negative pi over 4, it would be negative 1. Tangent of 0, right, is again just y over x, so that's purely just 1. And if we start with an infinity, we should also end with an infinity. So this happens to be my pattern. Again, these numbers that start it, negative infinity and positive infinity, these really, again, are part of your vertical asymptote. Okay, so, and again, we can't multiply or add any number to it. We do the same thing for cotangent. So to find the intervals, this time for cotangent, we are going to solve this guy. 0, I'll put bx plus c there, and then pi. Because this time tangent is positive and cotangent is positive in the first quadrant. And if we think about your graph, what it looked like, notice that we started positively. So I want to start in the first quadrant. I want to end negatively. And that means if I continue around my circle, the cotangent is negative in the second quadrant. And then it starts again, positive, negative, and then this cycle just keeps repeating. Okay, and then same thing here, when there is no B and or C, then our intervals will be 0, pi over 4, pi over 2, 3 pi over 4, and pi. So again, these are your x's. So just like the same thing over here, these are your x's. And your cotangent pattern, again, is the opposite, which means these are your y's. I forgot to put that there, and these are your y's. So again, notice that it starts positively, so this time it's going to start with infinity. Pi over 4, we already figured out that that's 1. Pi over 2 is 0. And then we're right back to -1 and negative infinity. Again, these values right here, we can't ever do anything to them. These are purely your vertical asymptotes. Okay, so now that we've got some patterns, right? Let's figure out how to graph this. Okay, so let's go ahead and graph some parent functions over one period. So we'll graph tangent first, and then we'll graph cotangent. Okay, so again, it's a good habit. Even though these truly don't have an amplitude, they're the a value. It's important to kind of just be thinking about how that a value affects your graph. It's a positive 1, it's not really affecting our graph. But this is the most important part of your period, right? It's just pi over your b, so just pi. Again, I don't have my b value, I don't have a c value, so I purely get to use these x values. So negative pi over 2, and then this becomes negative pi over 4, 0, pi over 2, and oops, let's switch those. Pi over 4 first, and then pi over 2. And then our y values are going to be negative infinity to -1, 0, 1, and then infinity. Right? So again, not a whole lot of work that we have to do. So let's go ahead and draw an x-axis. And I'm going to make that a little bolder. And draw a y-axis. That looks like a good one. Again, make that a little bolder so we really get to see that. Okay. So let's go ahead and plot our points. Remember, we do want things evenly spaced, but the great thing about these are all evenly spaced already. So this gives you pi over 4. This is pi over 2. And then negative pi over 4, negative pi over 2. Okay, we're going to draw our asymptotes, so I'll draw these in purple. So our first number and our last number don't exist. Okay, and then we plot the rest of the information. So let's plot it in a different color. So negative pi over 4, oh, I forgot my y values. So let's go 1, negative 1. Okay, so negative pi over 4, and at -1, you're right there. 0, 0, and then 1. So notice that it kind of looks like it's a straight line. Again, we know that it's not. It's going to look more cubic than anything. So we're going to go ahead and we're going to try to the best of our ability, go through this, make it look cubic, coming down, and then we're done. All right, we're only graphing one period. I do want to see asymptotes on either side, and then these 3 points in the graph in blue. All right, so that's what your tangent graph's going to look like. Let's go ahead and graph our cotangent graph. So again, our amp, even though we don't really technically have one, it's really your a value. It's a 1. Again, there's no period change on this, so it just stays as pi. Again, there's no b value, there's no c value, so I know that my intervals are exactly the same as I wrote on that first slide. 0, pi over 4, pi over 2, 3 pi over 4, and pi. Those are my x's, but my y's are a little bit different, so I start high, and I start bringing that graph down low. All right, so this time again, I have more positive than I have negative, so I'm going to move my y-axis over just a little bit. And let's go ahead and this time I'm going to start with my y-axis since I'm always forgetting about those numbers. And again, it's all evenly spaced at pi over 4. And you don't have to necessarily write every single number down. And then pi, if we really wanted to. So I skipped the number. Now, when your asymptote is on an axis, again, it becomes a little challenging, right? So I'm going to use a highlighter this time. I'm going to highlight. That's your asymptote. And that's your asymptote. Okay. So again, pi over 4 is going to be at 1. Pi over 2 is at 0. And 3 pi over 4 is at -1. So it's in my number. Again, those blue dots kind of make it look like it's a line, but we know better. Looks like a curve. To the best of your ability, right? And that is what our graph over one period looks like. If we did have an a value that was negative, a tangent graph could potentially look like a cotangent graph and vice versa. Okay, so the last two examples have some changes in it, right? A's, B's, C's, and D's. If you want to try any of these problems first and then unpause the video and see how we do, I highly recommend it. If not, watch and what we're doing. Okay, so here's our third example. We're going to graph this one over 2 periods this time. So y is equal to 2 tangent x over 2 plus pi. So again, this time our a value is 2. Our period, though, notice I have a 2 in the denominator. So that means it's being divided by 2. So it's really 1/2. Division is the same as multiplying by the reciprocal. So multiply it by 2 over 1, and that gives me 2 pi. I do have a c value. So again, remember, you're never changing your first and last number. You're keeping that exactly the same. So blue means that's what we're changing. So the period just tells you how long from this guy to this guy once we manipulate the blue. So I'm going to go ahead and I'm going to subtract pi to both sides. Again, you can get pi to be the same denominator. So that's really 2 over 2. Right? So this should give us a negative 3 pi over 2. And then this will just be x over 2. And then this will be a negative pi over 2. I will go ahead and I will multiply everything by 2. And you will have negative 3 pi all the way to x, all the way to negative pi. So again, notice the start, which is our vertical asymptote, negative 3 pi. The end, which is also a vertical asymptote, is negative pi. The distance is 2 pi. All right, so let's go ahead and find our points in between. So negative pi. Again, negative 3 plus negative 1 gives you negative 4. So in between, that should be negative 2. Combine those together, I'm going to get negative 5 pi over 2, and these will give me negative 3 pi over 2. So it looks like I'm going by pi's over 2's. So negative 6 pi over 2. This would be negative 4 pi over 2. Negative 2 pi over 2. Again, important so that way I know that I have a good increment. All right, so let's see. Again, I have more negatives right now, so I'm going to move my graph just a little bit more, potentially that way. Okay. Forgot my y values. My y values. So my y values for tangent start at negative infinity. Negative 1, 0, 1, and infinity. And I'm going to go ahead and I'm going to multiply this by our 2. So I'm going to get 2 times infinity. That just stays as negative infinity. Negative 2, 0, 2, and infinity. I'm crouching on my graph, so I'm going to go ahead and move both of these down just a little bit more. Okay. So let's go ahead. Now, I don't want my first number to be my very first increment. So I'm going to skip because that would be like a negative pi over 2. So this guy is the negative pi. And this guy is kind of like the negative 2 pi. And then this guy could be the negative 3 pi. I'm going to go as high as 2 and as low as negative 2. Draw my asymptotes. Again, I'll do them in a highlighter. So negative 3 pi and negative pi. And plot our points. So the first one is negative 2, 0, and 2. So the numbers are a little bit more stretched out. So again, we are approaching our graph. That does not look like a bad tangent, if I do say so myself. Okay, and then I can continue. And so notice that there are 3 spaces in between our 2 asymptotes. So let's make 3 spaces. So here's 1. My y-axis is 2, 3, then 4 would be my asymptote. So I'm going to draw 4 right here. Now, if I'm actually going by what I say I'm going by, this guy should be pi. And again, from negative pi to pi is still 2 pi. So I draw my second one. So again, -2, 0, +2. My increments are a little bit closer together because this is not graph paper. So I'm not as great on my second period as I was on my first period. But that's it. That's all you have to do. Okay. So let's try one more with cotangent. And this one does have a d value. So again, f of x, it could be -2 plus half of cotangent of 2x minus 3 pi over 2 periods. Again, I encourage you to pause the video, try this on your own. Remember that even though there's a -2 in the beginning, do not combine these 2 values together, right? This could be the same thing as if I wrote f of x is equal to 1/2 cotangent of what was in the parentheses and then -2. So they mean exactly the same thing. All right, so our amp is 1/2. Our period is divided by 2, so this will be pi over 2. I'm going to set up my intervals. So 2x minus 3 pi. And then to pi. Again, I could divide by 2, but I don't forget to divide everything. I think it's easier to add or subtract first. So I get 3 pi, 2x, 4 pi. I will then divide everything by 2. Bam. 3 pi over 2, x. And then this just is 4 pi over 2, or aka 2 pi. So either one is fine. And again, notice 3 pi over 2 to 4 pi, that is a period of pi over 2. So I know I did everything correctly. Okay, let's find our x's. So 3 pi over 2, blank, blank, blank. And I'm going to leave it as 4 pi over 2 because I have to add these numbers together. So if I start with the first one, all right, so this will give me a 7 pi over 2, divide by 2, which is the same as multiplying by 1/2. This will give me 7 pi over 4. All right, not too bad. I'm going to change my 3 pi. I'm going to make that 6 pi over 4. I'll add that with 7 pi over 4, which gives me 13 pi over 4. Again, multiply that by 1/2. I get 13 pi over 8. Ooh, okay. So I got 8s. So this would be the same thing as saying 12 pi over 8. 13, so this must be 14 pi over 8. So this guy must be 15 pi over 8. And notice that that's 16 pi over 8. Okay, so I found the correct increments. I'm feeling good. And then my y values. So cotangent, remember, starts high at infinity and then goes low to negative infinity. First thing I'm going to do, I'm going to multiply everything by 1/2. Right? So again, nothing changes. I get 1/2, I get 0, I get -1/2. So it just looks like my graph's probably been squished, right? Or vertically shrunk. And then I'm going to subtract 2. Now, when I subtract 2, again, let's change it to a denominator of -4 over 2. I need to subtract 2 to everything. But in reality, you can't do infinity minus a number. So the great thing is the first and last number stay exactly the same. 1/2 minus 4 over 2, that gives me -3/2. This would be just -2, and then -5/2. So I have my lovely y values. So when I look at my graphs, let's move this down. Looks like I have more positives and positive x's and more negative y's. So it looks like my graph's probably going to be like this. Yeah, that looks good. Okay. So I know I need to start at 12, so I'm going to start making some tick marks. So I know I'm pi over 8, and then 2, 3, 4, 5, 6, 7, 8. Let's just put 8 pi over 8, so at least I have something in case I forget. 9, 10, 11, 12, and I'm for sure going to put 12 pi over 8. 13, 14, 15, 16. Ooh, just made it. All right, I want to go as low as -5/2, which is, I'm going to go by halves. So I'm going to make this -1, -2, and -3. Okay, so my first one is my asymptote. My asymptote is going to be here and here. So let's make an asymptote. Let's make an asymptote here. And then my numbers are here. So my next one's -3/2. So go down 3 spots, go down to -2, and then finally -5/2. So it should look like that. And again, I can make my second period. I just have to count 3 more. So 1, 2, 3, and then my 4 is going to go right there. And again, my period is between a pi and a 12 pi over 4, because again, pi and 3 pi over 2 is still a period of pi over 2. And again, I repeat this process one more time. So -3/2, -2, and then -5/2. So try to make the second period look like the first period, and you're done. Again, you could have gone positively, could have gone that way. Again, we can actually make quite a number of periods on this cotangent. And that is how we graph tangent and cotangent.